Third type of compounds we're going to learn to name are acids. So acids are molecular compounds, but they release hydrogen ions when they're dissolved in water. So the compound itself does not contain ions, but it ionizes in water. So acids are composed of hydrogen and one or more nonmetals, and the hydrogen is always written first. You'll learn a lot more about acids later, but I'm just giving you what you need to know now. So HCl, this is a molecular compound. Hydrogen and chlorine, both nonmetals, right? And we could name that hydrogen monochloride. It's a molecular compound, but when you put it into water, it ionizes, and it forms hydrogen ions and chloride ions. And when we write AQ in parentheses after a substance's formula, that just means it's dissolved in water. Aqueous, like agua, water. If the compound like this is something that does not dissolve in water, then it would not be considered an acid. So some people get real picky about, well, you name this as a molecular compound unless it's dissolved in water. So if you don't have the AQ, you can't name it as an acid. I'm going to try to stick to that, but again, that's not a thing I'm going to try to trick you about. Acids have some common characteristics. They have a sour taste. My kids love Sour Patch Kids and all these extreme sour candies, and I'm like, ew. What makes them so sour?
Acid.
It's acid, yeah. They are weak organic acids, and so they're not harmful to you, but they really taste sour. Acids can dissolve many metals, not all of them, but here's an example. You're actually going to see this reaction possibly in lab today, and so a zinc metal will react with hydrochloric acid to form hydrogen gas and zinc ions. And so there's a question in your post lab that asks you about this, and this slide is really the only way you would have any chance at knowing what the gas is. It's hydrogen. The formulas for acids start with H. So HCl, H2SO4. So if you see a formula that starts with H, you should think that's probably an acid, because in this class it is. Two types of acids, and they're named different ways. So there are oxyacids. Oxyacids have oxygen in them. So these are hydrogen and one of those oxyanions we've learned about. So those are the oxyacids. These are called binary acids containing only two elements. I don't like that name because there's at least one that has three elements and still falls in that category. So I call them the oxyacids, and then kind of the ones that aren't. So for those that aren't, no oxygen, we're going to follow this pattern. We use the prefix hydro. Come on, pointer. Hydro. And then we take the name of the nonmetal. There's hydrogen and something else. We change the end of that nonmetal name to ic and add the word acid.
Are you recording the session? Because last week you did.
Yes,
Okay.
I am recording the session. Thank you. I actually found the missing video.
Did you?
Yeah, I did. I don't know what happened, but I found it.
I just want to make sure.
That's good. That's good to make sure, because I do stuff like that. Okay, so hydro blank acid. Okay, so we change the ending of the name, not to "ide" like we've been doing, but "ic." So let's look at this. Here we have HF, and it says AQ after it. Because we're trying to be technically correct, we would only name this as an acid when it's dissolved in water.
So would that be hydrogen chlorine if it was a gas?
It would be hydrogen monofluoride.
Monofluoride?
Yeah, if it was a gas. But here it's named as an acid. So we start with the prefix hydro. Okay, that takes care of the hydrogen. And then we take the name of fluorine and change the ending to ic. So fluoric, hydrofluoric, and then the word acid. Did I already point out to you that that fluorine has no flour in it?
Yeah.
Okay. Yeah, question?
So the hydro prefix comes from the fact that there's no oxygen?
Yeah, so we'll only see this hydro prefix when there's no oxygen in the acid. And there's really only a handful of these acids. There's hydrofluoric, hydrochloric, hydrobromic, hydroiodic, hydrocyanic, hydrosulfuric, hydrophosphoric. There might be hydronitric. I don't think so. But there's just a limited number of them. So the oxyacids. The oxyacids contain an oxyanion, and so the name of the acid is based on the name of that oxyanion. So we're going to just alter the name of the anion and add the word acid. So if the ion's name ends in ate, we're going to change that to ic and add the word acid. If the ion name ends in ite, we'll change it to us and add the word acid. So you have to remember that ic and ate go together and ite and us go together. So Rick ate him before he could bite us. I'm having trouble. Ate him before he could bite us. And there are other ones. I'm not sure because I've been using this for so long. I think I made this one up myself, but
The white mouse.
the white mouse ate icky cheese. That's the other one, another one that's real common. The white mouse, so here you have ite and us, ate icky, because you've got your ate and your ick, ate icky cheese. Or you can make up your own, right? You just have to associate those with each other correctly. Okay, so here we have an acid, HNO2 aqueous. It starts with H, and we've got the AQ there. This is an acid. We look at it, and we see that it has oxygen in it. So what we're going to do is we're going to cover up all the hydrogens. Sometimes there's more than one. And we're going to look at that NO2, and we're going to say, what's the name of that anion? That's nitrite, right? So we've got NO2 in here, and that's named nitrite. So we change the ending of ite to us. Bless you. We get nitrous acid. Any questions? It's something you have to practice. Go through it and practice it. And then at some point it'll click and you're like, oh, that's so simple. So you just have to persist until you get to that clicking point. So what about writing a formula? Yeah, question.
So we don't say hydrogen because there's the O there, right?
Correct.
Okay.
So the hydro prefix is only for the binary acids.
Do binary acids never have oxygen?
Binary acids never have oxygen because the only one that could be binary with oxygen would be H2O. And what's that one? Water. Water is not named as an acid. Okay, let's look at this formula. Write the formula for this acid, perchloric acid. So because there's no hydro prefix, I know that this has an oxyanion in it. So perchloric, that ic changes to ate. So this is perchlorate ion with hydrogen ions added onto it. So perchlorate ion is Cl O4 with a -1. Hydrogen ions, hydrogen hangs out in group 1, has a +1 charge most of the time. So when I put the number of hydrogens on here, all I have to do is look at the charge on the anion. If it's -1, I need 1 hydrogen. If it's -3, I need 3 hydrogens. So H ClO4, and then technically correct, put aqueous there. Any questions?
So every acid is going to technically have the parentheses.
Say that again?
Every acid will have parentheses aqueous after the.
It should, yeah. So here we have two names, chloric acid and hydrochloric acid. Because every compound has to have a unique name. It could have more than one name, but a name can only refer to one specific compound. So these both have chlorine, right? So hydrochloric, what does that prefix hydro tell me?
Binary.
It's binary. There's no oxygen, right? So that's got chlorine. And then how am I going to predict how many hydrogens go with that? I'm going to look at the periodic table because what acids do is they form ions in solution so their ionic charges can allow us to predict their formulas even though they are not ionic compounds. So chlorine would be a -1, and then we'd only need one hydrogen. So HCl.
Oh.
Yeah, I'm making stuff up right now. I'm improvising. Okay. So then what would chloric acid be?
It's got an oxygen, right?
It's got oxygen in it. So chloric comes from chlorate, right? So chlorate, ClO3 minus, because we memorize it. It's got a -1 charge, so I just need one hydrogen. And then to be technically correct, I should put AQ back there. So chloric acid and hydrochloric acid. Their names are similar. And their formulas are similar, but one has oxygen and one doesn't. Any questions? So I kind of already went over this because I always forget what slide's coming next. It's, how I make my life exciting. So if you see a name and it has the word acid in it, guess what? It's an acid, right? Then the formula is going to start with H, and you use ionic charges to predict the formula even though it's a molecular compound. We see the prefix hydro. That means it's a binary acid. If there's no prefix, then it's an oxyacid. And for writing the formulas, we just take the white mouse ate icky cheese thing and do it the other way. So a little more practice. Let's write formulas. Hydrocyanic acid. Is this an oxyacid? No, because it has hydro in front, right? So this is going to be hydrogen ion and something else. Cyanide. Cyanide is a polyatomic ion, but it does not have oxygen in it. And it does form an acid. And so the formula is HCN aqueous. And that's why I don't like to call these binary acids, because that one's not binary. Yes?
Since it ends in IC, so IC usually relates to ATE, right?
Mm-hmm.
But there is no cyanate, which is cyanide.
Right. So normally we would take this ic and change it to 8. But we have the prefix hydro on here.
Got it.
And so then we don't. So phosphoric acid. Oxyacid or other kind? It's an oxyacid because it does not have hydro in the front. So now we're going to change the ic to 8. And this part goes away. So this is from phosphate. So we write the formula for phosphate, PO4, 3 minus. How many hydrogens does it need? 3. Because hydrogens are H+. So H3, PO4, aqueous. Hypochlorous acid. Oxyacid or other kind? Oxy. Okay, hypo and hydro kind of look similar, right? They've both got the H, the Y, and the O, but in the middle it's a little different. Hypochlorous. So us is ite. So this is from hypochlorite ion. ClO, -1 charge. We're putting that together with the hydrogen ions, and so we just need one of each, HClO, aqueous. Yep. Any questions? This is just an illustration of what acid rain can do. I'm not going to test you on acid rain, but I think it's interesting. So here are two statues, and this one apparently was covered by an eave or something and didn't get rained on as much as its neighbor. And this one you can see has just been eaten away. And this is from acid rain. So certain pollutants that get into the atmosphere through us burning gasoline in our cars and other things, things like NO, nitrogen monoxide, nitrogen dioxide, sulfur dioxide, sulfur trioxide, these can form acids when they get mixed with water. So we get H2SO2, H2SO3, HNO3, HNO2. So these combine to form acids. Well, this happens in the atmosphere. And then the rain that comes down has some acid in it. Now, it's not going to eat your fingers off immediately. This damage to this statue probably happened over hundreds of years. But acid rain is a real thing. It gets into the soil and can cause significant damage to trees. It runs down into lakes and rivers and can cause problems for aquatic life. And so it is a big problem.